Okay, hello everybody. Well, this is our suggested constellation spot for the month, in this case July. Now here's a picture of the area of the sky where this constellation is to be found. As you'll see, it's not that obvious which is the constellation because the stars within it are relatively faint. They're what we call third magnitude stars. But if I pop on, if I can get it to work okay, the lines, you'll see that's the shape of it, Hercules. Now perhaps you can make out the stars that were involved. So Hercules, quite close to last month's constellation of the month, which was Bootes. Now I like to use these when I can. These are tea cards that came with our packets of tea when I was a lad. So it was a series called Out into Space, and the picture they have for Hercules is like that. And there's the description. But I'll just make that a little bit larger for you. We have learnt quite a bit more since those days and Brook Bond, so the position of the globular cluster isn't quite right. It's a little bit higher, it's up there, and certainly more than 1,500 stars. It's the best part of 300,000 stars, so we now learnt quite a bit more. But as you can see, that's the shape of the constellation. Hercules, who was the son of Zeus. Now it is actually quite a large constellation, takes quite a large part of the sky, but it's not so easy to find. So here's the text for how to find it, and I'll show you that on the next slide. But if last month you found your way to Bootes, then you're halfway there. Get to Arcturus, and then go up the side of Bootes and then look for, following that line, a very bright star called Vega, and Hercules is halfway in between. And as this text says, there's a couple of really fascinating objects to be found inside there. M13 and M92, both of them are known as globular clusters. So here's where to find it. So for those of you that haven't found your way to Bootes, start with the Great Bear. Everyone can find your way to the Great Bear, or the Plough, this part of it called the Plough, or the Big Dipper, and follow that tail round as if it was a curve. And this is what you'll get. A curve takes you round to Arcturus, the prime star of Bootes. Then from there, go up the side, the left-hand side of Bootes, and that leads you onto the bright star Vega. And Arcturus is that set of rather dim stars in the middle. Watch out for that shape in the middle there, that sort of anvil-like shape, if you wish. Now, whilst we're at Vega, unmistakable, very bright, bluish white in colour, that's one of three stars that Patrick Moore formed into a group that he liked to call the Summer Triangle. That's made up of Vega, then to Deneb, the prime star of Cygnus the Swan, then down to Altair, the primary star of the Aquila, the Eagle. And those three form a nice right-angled triangle. And Patrick Moore, quite rightly I think, said if you can find those stars in the triangle, then you can use those three as pointers to other constellations. So it's a good idea to learn that little area of the sky and see how you can compare that with whatever star map or planetarium program you have as an app or on your computer, and learn your way around the night sky. Now let's have a look at Hercules itself and see what is to be found within it. So here you can see M13, the globular cluster, identified, and also so that's halfway between these stars. You'll notice these maps use, as astronomers do, the Greek alphabet. So this is Zeta and this is Eta. Hercules. So it's about 2/3 of the way up between Zeta and Eta is where you'll find M13. Even a pair of binoculars, a small telescope, will reveal it as a fuzzy patch made up of, in fact, as I say, hundreds of thousands of stars, a long way away, but tightly balled together. And there's another such cluster, not on one of these lines drawn here, but if you imagine there's a line between Eta and Iota, then it's just about halfway, just a little bit over halfway between them. So there's M92, just a little bit further away than M13. More of that later. But the constellation has an awful lot of double stars, as you'll see from this graphic. And when I show the double star, I'll show the magnitude, the brightness of the two component parts of the double star. And so the lower the magnification number, the brighter the star. So this one has one bright and one faint component. This one has two equally faint components, as does this one, and so on. A variable star, this one's quite interesting. You'll note that it can be twice as faint as, or rather its magnification so it is way down to, but well beyond the level that could be seen by even a small telescope. So sometimes that star is not visible at all, and then it's just about visible with a telescope or a pair of binoculars. So if you're interested in that sort of thing, hunt it and see whether you can spot it. Here's an image of M13, the great globular cluster in Hercules. It's also known by a catalogue number, the new general catalogue 6205, and it's 25,000 light years away. Can just be seen, if you know where to look with the naked eye, as a looks like a star. But a small telescope will reveal it as a fuzzy patch. A larger telescope, mine will show it something like this. And it was discovered in 1714 by Edmund Halley, he of Comet Halley fame. So just imagine what it must be like if you were in a civilization, in a planet, in one of those stars. There's 300,000 stars in that group, in a separated across, well, the diameter of this is about 100 light years or thereabouts. And when you think our nearest star is Alpha Centauri, 4 light years away, that Sirius, the brightest star, is about, if I remember rightly, 10 light years away. Just think how many stars there would be packed into those sorts of distances if you had that kind of density. 300,000 stars spread in only 25 times the distance between us and our nearest star. You just wouldn't get a night, a dark night. It would be brilliant all the time. And here's a similar cluster a little bit further away, 26,700 light years away, discovered quite a bit later by Johann Elliott Bode in 1777, M92. It's as glorious a sight in a good telescope. So try and find them in a small telescope or in binoculars, and know that you've seen something where the light that you're looking at took 26,000 years to get to you. So there we are, there's Hercules, my constellation of the month for July.